Right. Solving rational equations. You already know how to solve these. We've done this before. We're going to use cross multiplication, so we'll cross multiply x times 5 is 5x, 3 times 9, that would equal 27. And then divide by 5, and x equals whatever 27 divided by 5 is. See, 27 divided by 5 would be 5.4. Okay, and then the next one, same thing, cross multiply. 4 times x is 4x equals 7 times 6 is 42. Divide by 4, x equals 42 divided by 4, which is 10.5. Okay, the next one's a little trickier. We've got 30 over x plus 8 equals 15 over x minus 2. And we're going to cross multiply these just like we did those up there. So 30 times x minus 2 is 30 times x and 30 times negative 2. So we'll have 30x minus 60 equals, same thing with 15 times x plus 8. 15 times x is 15x plus 15 times 8, which is 120. And then we'll get x's on one side and numbers on the other. And let's subtract 15x first from both sides. 30x minus 15x is 15x minus 60 equals 120. And then we can add 60 to both sides. So 15x equals 180. And then we'll divide by 15. And x equals 180 divided by 15. Which is 12. Okay, so what is the method that you use? We use cross multiplication. Why does this method work? Okay, back when you learned about fractions, you learned that 1/2 is the same thing as 5/10. So 1/2 equals 5/10. And then you learned that when you cross multiply these, 1 times 10 is 10, 2 times 5 is 10, that their cross products were equal. So this method works because cross products are equal. When you use cross products, you are really multiplying both sides by the least common denominator. Okay, so we're going to use cross multiplication whenever we can. For example, in number 1, we're going to use cross multiplication. But we do have to worry about one thing. It says state any domain restrictions that would make the denominators equal to 0. Okay, so what number could we put in here for x that would make this denominator equal 0? Well, if we plug in -3, then -3 plus 3 would be 0, and we are not allowed to divide by 0. So we're going to say that x cannot equal -3. Then in this denominator, if we plug in 4, 4 minus 4 would give us 0, so x cannot equal 4. Okay, and then this is a problem where we can cross multiply. And when we do get an answer, if we get a -3 or if we get a 4, then we'll know we can't use that answer won't work. And so if we do get one of these, then we may end up with no solution, but we'll see what we get. So we're going to multiply 4 times x minus 4. That would be 4. Let's go ahead and multiply it out. 4 times x would be 4x. 4 times -4 would be -16. And then that equals, because their cross products are equal, so 7 times x is 7x, 7 times 3 is 21. Okay, and then let's go ahead and subtract 4x to keep the x's positive. So we have -16 equals 3x plus 21. Then we'll subtract 21. And we get 3x equals -16 minus 21, which is a -37, and then divide by 3, and x equals negative 37 divided by 3. You can either leave it as a fraction, which in this case we get a repeating decimal. So we're going to want to leave this as a fraction. Negative 37 over 3. And then we check our restrictions, and since this is not either one of our restrictions, then this is an answer. That is the solution. So if we plugged in negative 37 over 3 for x here and here, then these would be equal. Okay, can we use cross multiplication here? No, we can't, because cross multiplication is a fraction equal to a fraction, and over here we have two fractions on the left. So we cannot do that. So we're going to come up with another method, and it's called the least common denominator method. We're going to multiply every fraction by the least common denominator. So first, before we do that, let's look at restrictions. And what could you plug in here for x that would make this denominator 0? Well, if we plug in 0, we'll have 1 divided by 0, and we can't divide by 0. So we're going to have x cannot equal 0. Okay, same thing here, x cannot equal 0. 3 is fine, but all that matters are where your x's are. Okay. All right, now we need to figure out what the least common denominator is. Okay. Now, least common denominator is a denominator that includes all of these denominators. So we're going to need an x, and we're going to need a 3. Now, we already have this x, so what we're going to have is a 3 for this one, and an x for this one, and this x also takes care of this x. So our least common denominator is 3x. Every different denominator has to be included. Everyone wants to be included. No one wants to be left out. Okay? So then we're going to take our least common denominator, which is 3x, and multiply each fraction by 3x. So 3x times 1 over x. Write that down. 3x times 1 over x plus 3x times 13 over 3. And I'm going to put parentheses around my 3x to show that I'm multiplying, equals 3x times 7 over x. Okay, now the reason we're doing this is because all of these denominators will go into the least common denominator, and they're going to cancel out. So we can cancel out these x's because we have a single x on the top and a single x on the bottom. And then what is left we will multiply together. So 3 times 1 is 3. Plus, okay, now these 3's will cancel because we have a 3 on the bottom and a 3 on the top. And then we'll multiply what's left. So that's x times 13, which is 13x, equals x's cancel. We have 3 times 7, which is 21. And then we just solve it like a normal problem. What's awesome about this method is that all of the denominators disappear. Okay, so let's subtract 3. So we have 13x equals 18. Then divide by 13, and x equals 18/13. Okay, now we check our restrictions. We did not get 0. We got 18/13, so this is the solution. If we had gotten x equals 0, then we would have no solution. Okay, let's turn it over to the back. Look at number 3. Okay, we can't use cross multiplication because we still have 1, 2 fractions on the left. This is a whole number, but we can make it a fraction by putting a 1 under it. Let's first look at whatever restrictions we might have. So we only have to look at the x. What could we put in there for x that would make that 0? Well, if we plug in 3, 3 minus 3 would be 0, and then we'd be dividing by 0. So x cannot equal 3. That is our restriction. Okay, and then we're going to find the least common denominator next. Okay, so remember, every denominator that is different wants to be included. So this denominator, x minus 3, they are married to each other by that minus sign. So they are a married couple. You cannot split them up. There are no divorces. So we're going to need x minus 3 as one of our denominators, one of our least common denominators. And then this 3, even though there's a 3 here, these are not separate. They go together, and this 3 is single. So we need that single 3. It is not the same. This 3 is not the same as x minus 3. Okay, and then we need a 1, but 1 will actually go into 3. So I have to really put a 1 here. So we're going to multiply all of these fractions by 3 times x minus 3. So we'll have 3 parentheses x minus 3 times x over x minus 3 plus 3 parentheses x minus 3 times 1 over 3 equals 3 parentheses x minus 3 times 1 over 1. All right, so since we have an x minus 3 on the bottom and an x minus 3 on the top, a married couple can cancel out with a married couple, and we have 3 times x, which is 3x, plus a single 3 can cancel out with a single 3, and we have x minus 3 times 1, which is just x minus 3, equals nothing here to cancel out. We just have 1 times 3 times x minus 3. So 1 times 3 is 3, and then we'll do 3 times x, and 3 times negative 3. So 3 times x is 3x, and 3 times negative 3 is negative 9. Then we have 3x plus x, that's 4x, minus 3 equals 3x minus 9. And then we're going to subtract 3x, okay, and that gives us x minus 3 equals negative 9. And we can add 3, so x equals negative 6. And then we'll check our restrictions. Negative 6 is not a restriction, so this solution is fine. Okay, number 4. Right? We're going to put a 1 underneath that x so that we have all these fractions and we can't cross multiply. So we're going to use the least common denominator method, and we're going to find the restrictions. So all I have to do is look at x and the denominator. X in the numerator does not matter, but in the denominator, if we plug a negative 2 in here for x, negative 2 plus 2 will give us 0. So x cannot equal negative 2. And then we need the least common denominator. Well, we have an x plus 2 here, so we need an x plus 2. We have a 1. We do not have to include the 1. That's automatic. And we have an x plus 2, and we already have x plus 2. So we're going to multiply everything by x plus 2. So x plus 2 times x over x plus 2 plus x plus 2 times x over 1 equals x plus 2 times 5x plus 8 over x plus 2. All right, so we'll start canceling out now. X plus 2 cancels out with x plus 2. We just have x plus x times x and x times 2. X times x is x squared. X times 2 is 2x equals x plus 2 cancels out with x plus 2. We get 5x plus 8. Okay, now this one's different than all the others because it has an x squared. And that means it's a quadratic. When it's a quadratic, it means we're going to get 2 answers, and we want to set everything equal to 0. So we're going to keep this one positive and keep it here. Let's go ahead and combine the x and the 2x. So we have x squared plus 3x equals 5x plus 8. Then we're going to move these two over here to the left side. So we'll subtract 5x and subtract 8. And the 5x's cancel and the 8's cancel out. So we have 0 on the left. On the right, and on the left we're going to have x squared. 3x minus 5x is negative 2x minus 8, and that is 1 equals 0. Now, when you have a quadratic set equal to 0, we want to factor into 2 parentheses. So x squared would be x times x, and 8. Let's try 4 times 2. And we need to get a negative 2, so if I make the 4 negative and the 2 positive, then I have 2x minus 4x is negative 2x. And then we set each, after we factor it, we set each parenthesis equal to 0. So we have x minus 4 equals 0 and x plus 2 equals 0. Add 4, so x equals 4, that is one of our answers. Subtract 2, so x equals negative 2. That is our other answer. Then we have to check with our restrictions, and we said that x cannot equal -2 because if I plug -2 in here, I'm going to get a 0 in the denominator. So we're going to mark this one out, and this is our answer. Okay, last one. Okay, notice something different too about this one is that the denominator can be factored. And you want to look at your denominators and see if any of them can be factored, and if they can, that's what we're going to do. So we're going to factor this one, x times x. And 6 could be 6 and 1 or 3 and 2. Let's try 3 and 2. And if they're both positive, then we'd have 2x and 3x would give us 5x. So we mark this out. Mark this out good because you don't want to use this anymore. You want to use x plus 3 over x plus 2. Okay, so now we need to look at the restrictions. If I plug in a -3 here, -3 plus 3 is going to give me 0. So x cannot equal -3. If I plug in a -2 here, -2 plus 2 is going to give me 0. So x cannot equal -2. If I come over here, -2 would give me 0 and -3, and I already have those. Okay, so now we're ready to get the least common denominator. Okay, I know I need this x plus 3. And I know I need this x plus 2. Okay, and then here's another x plus 2. I already have that. Here's an x plus 3, and I already have that. So every one has been included in the least common denominator. And now I'm going to multiply every one of these by x plus 3 times x plus 2. So we'll have x plus 3, x plus 2 times 3 over x plus 3, x plus 2, plus x plus 3, x plus 2, times x minus 1 over x plus 2 equals x plus 3, x plus 2 times 7 over x plus 3. Okay, so we're going to cancel out whatever we can. So we've got an x plus 3 on the bottom and the top, x plus 2 on the bottom and the top, and that just leaves us with 3 plus, have an x plus 2 on the bottom and the top, and now we have x plus 3 times x plus 1, and we're going to have to FOIL this. So x times x is x squared, and then x times, whoops, wrong x. We got to go from this x to this x. And then x times -1 is -1x. 3 times x is 3x. 3 times -1 is -3. Okay, then that equals, the x plus 3's cancel. So I have x plus 2 times 7. So I'm going to distribute the 7. 7 times x is 7x, plus 7 times 2 is 14. Okay, then I'm going to combine whatever I can. So the 3 minus 3 cancels. So I have x squared, and then -1x plus 3x is 2x. So x squared plus 2x equals 7x plus 14. Now I've got a squared, got a quadratic, so I want to get everything equal to 0. So I'm going to subtract 7x and minus 14, minus 7x minus 14. So I have 0 on the right, and on the left I'm going to have x squared minus 5x minus 14. Okay, now from there I can factor. So I have x times x and 7 times 2 plus and minus, except I think I need to do minus 7 plus 2. That gives me 2x minus 7x, which is -5x. Now I'm going to set each one of these equal to 0, so x minus 7 equals 0, and x plus 2 equals 0. So x equals 7, and x equals -2. Then I need to check my restrictions. I notice that -2 is one of my restrictions, so I can't use that solution, but I can use x equals 7.